In this video, we will be solving a system of linear equations by Gaussian elimination. And before I get too much further, this should be a positive 3 here. And for this example, you can see that we will have 3 equations with 3 variables missing, or 3 unknowns. So the first thing you want to do to solve by Gaussian elimination, this implies that we will be using matrices, is to write this in matrix form as an augmented matrix. In this video, we will solve the system by Gaussian elimination. And Gaussian elimination just means that we're going to translate this system here over into an augmented matrix and then do the math within the augmented matrix until we get a system that is easily solved. So the first step here would be to turn this system into an augmented matrix like this. And just for a reminder for everybody who's watching this video, the first column is all the x values, the second column is all the y values, so on and so forth, third column z's, fourth column constants. So we will have x's, y's, z's, and constants. And lastly, this vertical bar represents the equal sign in all of these equations. And also very quickly, the first equation here is represented by the first row. So one of the things that we are very interested in doing to make this matrix easy to interpret is we want to get ones in the main diagonal and zeros underneath all the ones if we can. So it seems like we're already on the right track. We have a 1 here. And even if there was not a 1 here, usually you can row swap with one of these other 2 rows to get a 1 in row 1, column 1. But now, since we already have a 1 here, our next objective is to zero out the rest of the column. You can only get zeros in matrices by adding or subtracting. And in order to add or subtract to 2 to get a 0 is to add a -2 to that. Well, the reason we have this 1 here is so we can make this a very easy operation. So if I take -2 times row 1, I would be able to get a -2 in the first position here. But I also have to multiply the entire rest of the row by -2. So this would be -2, -4, +2, -6. And that's what happens when you multiply -2 across this top row. Now, since we're trying to get a 0 here, I really want to add this to row 2 because that's where the 2 is and that's where we're trying to get a 0. So row 2 looks like this: 2, 7, -8, and 15. Now if I go and add these 2 rows together, I would get 0, 3, -6, and 9. So what do I do with this? Well, we've got success in getting 0 in the first position. I want to replace this current row 2 with this one. And so when I do that, the matrix will look something like this. So here is what the new matrix looks like with row 2 getting replaced with this new row, and we have a 0 underneath our 1. We're starting to zero out the column under the 1. Now this is all fine and dandy, but how do you write this mathematically? How do you write the step to get from here to here? This is all the work, but the step looks something like this. This would have been -2 row 1 plus row 2, and that replaces the current row 2 because that's where we're trying to get the 0. So on the next slide, I will copy this matrix and make sure it is on the next slide, and we'll start there. So here is the matrix from the previous slide as promised. Now we are trying to finish zeroing out this column right here. So I need this 3 to become a 0. And again, you can't get 0 in a matrix with a row operation anyway, without adding and subtracting. So we're going to have to add 2 rows together here somehow, so that we end up with a 0. So we know it's going to involve row 3, and row 3 is what's going to be replaced. But what do we add to row 3 to make sure we get a 0 here? Well, we can multiply row 1 by -3. That'll give us a -3, so when we add it to row 3, we'll end up with a 0. So -3 row 1 plus row 3 replaces the current row 3. So what that looks like will be -3 row 1 would be -3, -6, +3, -9. And I just, again, multiplied across the entire row by -3. Row 3 is 3, 7, -2, and 6. So when you add these together, you get 0, 1, 1, and -3. So that will replace this row 3 right here, like this. So here you can see the bottom row was replaced with this new result over here that gives us that 0 in the spot we want it. Now we've totally zeroed out the column underneath this 1. So the next step we want to do is get a 1 in row 2, column 2. So we want to get a 1 right here. Now there are a couple ways this could be done with this particular matrix. We could either row swap these two, or if you notice, each number in the second row can be divided by 3, and that includes 0. So the way I teach my students to do this is that we should just go ahead and divide by 3. But if you're not one of my students, you can easily row swap and start solving. Either way, we have to do an extra row operation here. So I'm going to write divide row 2 by 3 and replace the existing row 2. And so that matrix will look like this. So here I've taken row 2 and divided all the elements of that row by 3. So now we have that 1 in the row 2, column 2 placement, and we want to zero out the rest of the column beneath that 1, like we did over here. We zeroed out beneath the 1. Now we need to zero out beneath this 1. So since we're trying to get a 0 here, we will need to add and subtract and possibly multiply. So I think what's going to happen is we will multiply row 2 by -1 and add it to row 3 and replace the existing row 3. Now you might be wondering why we would not use row 1 for this, and that's because if we use row 1, we will change this 0 value to something that's not 0. We want to leave this as 1 and then have the rest of the column zeroed out underneath it. If we go back and use row 1, we will change this value. So we need to use only rows 2 and 3 to get a 0 in this position. So the row operation off to the right will look like this. So simply multiply row 2 by -1 and write down row 3 and add them together to get this new row. And cool, we have a second 0 in this row. So when we replace it in the matrix, it'll look like this. So this row was replaced with this new row. And we got a 1 in column 1, row 1, zeroed out beneath it. We got a 1 in row 2, column 2, we zeroed out beneath it. Now we just need to get a 1 in row 3, column 3, and we can turn it back into a system of equations. We're almost done here. So I've gone ahead and done the next row operations since we're trying to get a 1 here. If you just divide the entire row by 3, we will get that 1, and the magic is done. Now we can just simply rewrite what we have in this matrix as a system of equations and use back substitution to solve our system of equations. So the system would look something like this. It's still true here. We have x's in the first column, y's in the second column, z's in the third column will equal some constant. And so the system will look like this. So there's your system, and now we can just rely on the math you know and love for solving this system. Z is -2, so we're going to go ahead and write our answer down here. And this will be as an ordered triple, x, y, z. So z is -2, that's great. So now we can go ahead and plug z into this equation, solve for y. Y ends up being -1. So when you substitute z in here, I'm going to write it out just so everyone can see here. Y minus 2 times -2 equals 3. This is y plus 4 equals 3, and subtract 4 from both sides, y equals -1. So there's that. Then we can substitute -1 into this top equation, and -2 for z into this top equation, and figure out what x is. And this video is already way too long, so you can do your own substitutions here and solve for x and get that x equals 3. I hope this video helps everybody out there.